Dear students, in the last class we discussed polarization of light and the methods to produce polarized light. What is polarization? It is a phenomenon of restricting vibrations of electric vector to a single plane, to only one plane, which is polarization. A polarized light, it can be produced by different methods. The methods are by reflection, refraction, double refraction, scattering, by selective absorption. Out of these methods, we considered or we discussed only two methods. The methods are by reflection and by double refraction. What is double refraction? It is a phenomenon in which a light, when it passes through an anisotropic crystal, splits into two rays or two beams. This phenomenon is called double refraction, and the rays are called as E ray and O ray, extraordinary ray and ordinary ray. This is double refraction exhibited by anisotropic crystals. What are anisotropic? Crystals having different properties in different directions are anisotropic. Isotropic crystals, they do not show double refraction. Isotropic means light properties remain same in all directions or at all the points of that crystal. So anisotropic crystals, they exhibit double refraction. These things we discussed in the previous class. And the crystals are again classified as uniaxial and biaxial. Uniaxial means crystal having only one optic axis is called uniaxial. Crystal having two optic axes is called biaxial. And the E ray and O ray, they differ in their properties. The E ray has got the same property at all the points of the crystal or in all directions. It travels with the same speed in all directions. So refractive index of the crystal is constant for O ray. Whereas E ray, it travels with a different speed in different directions. So refractive index of the crystal in different directions for E ray. And these things we studied in the previous class. And about optic axis. What is an optic axis of a crystal? Suppose we have an uniaxial crystal like calcite or quartz. Let the crystal be cut to have 6 faces. And there in the crystal there will be two opposite corners having all the 3 angles obtuse. There are 2 corners in the crystal wherein all the 3 angles are obtuse. In calcite, the 3 angles are 120 degree each. See, these are the 2 corners wherein all the 3 angles are 120 each. Such corners are called blunt corners. Then a line passing through the blunt corners is called as optic axis. Is optic axis a line through the blunt corners? Actually, it is not a definite line. It is the direction. The direction through the blunt corners is called the optic axis, and any direction parallel to that particular direction is also the optic axis. Any direction parallel to this optic axis is also the optic axis. So optic axis in a crystal, the direction through the blunt corners of the crystal. And one more thing is, suppose light enters the crystal along the direction of optic axis, say in this direction. Then no double refraction occurs along this direction. Light does not show double refraction along the optic axis. So we define optic axis also as the direction along which there is no double refraction. Double refraction does not take place. Why double refraction does not occur? What would be the reason? Because the light, it travels with the same speed along the optic axis. Since both the rays, E ray and O ray, since they travel the same speed along the optic axis, no double refraction occurs along the optic axis. This is about optic axis of a crystal. Then in a crystal, the plane of the crystal, if you consider cross section, plane of the crystal containing the optic axis, then that plane containing the optic axis and which is perpendicular to the opposite refracting face of the crystal is called as principal section of the crystal. Principal section is plane containing the optic axis and perpendicular to the opposite refracting face of the crystal is principal section of the crystal. For a crystal having 6 faces, there are 3 principal sections. This is about optic axis. Now, Huygens theory of double refraction. The double refraction phenomena is explained by Huygens by applying his wave theory. According to Huygens' wave theory, light spreads out in the medium in the form of waves. And to explain the spreading of light in the form of waves, Huygens assumed the wave nature for light. So light spreads out in the form of waves. To explain the phenomena like interference, diffraction and polarization, he considered the wave theory. He used wave theory. Then he considered the idea of wavefronts. What a wavefront is? Wavefront is nothing but the locus of the points in the medium which are vibrating in the same phase. It's called the wavefront. He considered the idea of wavefront to explain this double refraction. So we have discussed this one in the previous class. Wavefronts are nothing but locus of the points vibrating in the same phase. The wavefronts, there are three types: spherical wavefront, cylindrical wavefront and plane wavefront. When the source is a point source, the wavefront is spherical in shape. Because a point source, wavefront is spherical in shape. The wave spreads out in the form of concentric spheres of increasing radius. So wavefront is spherical in shape. In case of a source having finite size, a linear source, in that case wavefront is cylindrical in shape. The spherical wavefront as well as the cylindrical wavefront at a larger distance, at a greater distance, is considered as a plane wavefront. Spherical or cylindrical at larger distance, greater distance, is taken as a plane wavefront. These are the three types of wavefronts. Using this theory or using the wavefronts, Huygens explained double refraction. Now let us consider an isotropic crystal. Isotropic means the property of the crystal same in all directions. So there is no double refraction. Suppose a point source is placed inside an isotropic medium, isotropic crystal or isotropic medium, say glass or water. Suppose there is a point source kept or embedded in that isotropic crystal or isotropic medium. This source sends out light in all directions. Light spreads in the form of wavefronts as per Huygens wave theory. Now here, light travels with the same speed in all directions. Isotropic medium, so light travels with the same speed in all directions. So that the locus of all the points vibrating or having the same speed, we get a circle or a sphere. The locus is a sphere, nothing but spherical wavefront. Thus, in the case of isotropic crystal medium, the wavefront is spherical in shape, so that the speed of light is same in all directions. We find only spherical wavefront, so there is no double refraction. Suppose the source is placed in an anisotropic medium, kept inside an anisotropic crystal like quartz or calcite say. So in that case, what happens is light is emitted by the source, then light splits. The splitting of light is observed. It splits into two rays. And also, he observed that Huygens or experimentally it is observed that out of those two rays, one ray is traveling the same speed in all directions, and we call that ray as O ray. So, O ray travels the same speed in all directions, so that the wavefront of that O ray should be spherical in shape. So, O ray is represented by the spherical wavefront. It is O ray. O ray, it is represented by the spherical wavefront. Other one is E ray. It travels with different speed in different directions, so that the wavefront corresponding to that E ray, that is found to be elliptical in shape. The wavefront corresponding to E ray is found to be elliptical in shape. Why elliptical in shape? Because the speed of E ray different in different directions. say along this direction speed is maximum, along this direction speed is minimum, and in all other directions speed is in between these two angles. This E-ray travels at different speed so that its wavefront is said to be elliptical in shape. And the theory also says that the two rays, they travel at the same speed along optic axis. See, along the optic axis there is no double refraction, indicating that both the rays, they travel at the same speed along that optic axis. Then along the optic axis, the two wavefronts, they touch each other. Since the rays, they travel at the same speed, the wavefronts touch each other along the optic axis. See, I have shown that one in these two diagrams. See here, what actually it is. Let us explain it later. Here, I have shown that the wavefronts of E ray and O ray are touching each other along the optic axis in both the cases. And this is how Huygens theory explains the double refraction. And depending on the properties of E ray and O ray in crystals, their velocity, the refractive index of the crystal for E ray and O ray, and the relationship between the refractive indices of E ray and O ray, depending on all these things, all these facts, the crystals are, the uniaxial crystals are again classified into two groups as positive crystal and negative crystal. The classification is positive crystal and negative crystal. Now let us see what are the differences between positive crystal and negative crystal. Say the example for positive crystal is quartz, that for negative crystal is calcite. See here, in case of positive crystal, see this is a diagram. You can see here the wavefront of E ray, the elliptical wavefront is well within the spherical wavefront, well inside the spherical wavefront. Spherical wavefront is for O ray, elliptical is for E ray. The elliptical wavefront is well inside that of the spherical wavefront. And see, this is the direction of optic axis, so that the two wavefronts, they touch each other along this direction. Now, see here, VO represents velocity of O ray, VE velocity of E ray, NE refractive index of the crystal for E ray, NO refractive index of the crystal for O ray. See here in the diagram. Here VE is found to be less than VO. VO equal to VE along the optic axis. VO equal to VE. In all other directions, which one is moving faster? The spherical is outer means VO is greater than VE. VO more than VE, or VE is less than VO. Why? Spherical is outside. So VO is more, or VE is less. So VE is less than VO. And what about NE and O? NE is more than NO. Refractive index and velocity, they are inversely proportional. You know the relationship between refractive index of the medium and velocity of light in that medium. It is N equal to C by V. Refractive index and velocity are inversely proportional. So here N is more than NO. Then what about NE minus NO? It is positive. That is delta. NE minus NO positive, delta, it is called as birefringence. So for a positive crystal, birefringence is positive. So since birefringence is positive, the crystal is called as the positive crystal. Since N is more than NO, Ne minus NO positive, so the crystal is called positive crystal. What about negative crystal? See here, we find the spherical wavefront well within the elliptical wavefront. Spherical wavefront inside the elliptical wavefront. The two wavefronts touch each other along the optic axis. Here they touch. So that VO equal to VE along the optic axis. VO equal to VE. Both the distances are same. They travel the same speed. In all other directions, which one is more? Elliptical wavefront is outside. So that V is greater than VO. Then NE is less than, actually NE less than NO. So that NE minus NO is negative. Birefringence is negative. So the crystal is called the negative crystal. This is how the crystals are classified. Uniaxial crystals are classified as positive and negative. So you can make out the difference, or you can list out the difference between positive crystal and the negative crystal. You can compare positive crystal with the negative crystal. What are the differences? One is, in a positive crystal, elliptical wavefront is within the spherical wavefront. Whereas in negative, Spherical is within the elliptical wavefront. For positive crystal, VE less than VO. Negative, VE greater than VO. For positive crystal, NE more than NO. Whereas negative, NE less than NE. Birefringence positive. And here birefringence is negative. These are difference. And one more difference you can make up. How many are over? 4. 1, 2, 3, 4 differences are over. One more. So here, in a positive crystal, velocity VE, velocity of the E ray, it is maximum. In which direction? Along the optic axis. See here, it is maximum. In all other directions, it is minimum. VE maximum along the optic axis. Whereas in negative crystal, VE maximum along the direction perpendicular to the optic axis. This is another difference. Here VE maximum along the optic axis. Here VE maximum along the direction perpendicular to the optic axis. These are the difference between positive crystal and negative crystal. And this is how Heisenberg's theory explains double refraction, why it occurs, and what about the wavefronts of the E ray and O ray and all these things, depending on the classification. All these explanations are given by Huygens using his wave theory and using the idea of wavefront. And this is about the optic axis and Huygens theory. With this, I stop here. Let us continue the next class with the another topic. It is to find the phase difference between E and O ray. Whenever double refraction takes place in a crystal, what is the phase difference introduced between E and O ray? Let us see that in the next class. Thank you.